Hello, this is Mrs. Decker, and this is Objective 1A on comparing and contrasting atoms, ions, and isotopes. So these are all pretty important vocabulary words that by the end of this lesson you should be familiar with and how they differ from each other. So we're going to start with some basics on how to read the periodic table. So here we have one tile from the periodic table and the information that it will contain. Now, each periodic table may contain slightly different information depending on what its intended purpose is, but each periodic table should have at least these four basic pieces of information. So we have our atomic number, which is usually somewhere in the top, whether it's in the center or the left or right corner. The symbol, which is the letter symbol for the atom, the name of the atom, and then the mass number. So the mass numbers you'll see will be decimals, and they're usually somewhere on the bottom of the tile, but they can be in different positions. So you need to realize that when you see that decimal number, that's the mass number. So the atomic number and the mass number are very important pieces of information about each element on the periodic table and tell us some pretty basic important things about the atom. So the atomic number will tell us the number of protons in the atom. And the number of protons is one of the most important defining characteristics of each individual element. So if the atomic number of a proton is 9, that means that that element has 9 protons. And now the mass number is going to tell us the number of protons plus the number of neutrons. So in theory, if we're adding the number of protons plus the number of neutrons, the number should be a whole number because you cannot have either partial protons or partial neutrons within an atom. However, the mass number that you're going to see on the periodic tables will be a decimal. We'll get into why that is in just a few minutes, but just know that the mass number is going to tell you the number of protons plus the number of neutrons. To find the number of neutrons in an atom, you're going to take the mass number and subtract the atomic number to find the number of neutrons. And then when we're dealing with neutral atoms, the number of electrons is going to be equal to the number of protons. Okay, so now we're going to use the potassium element tile from the periodic table to find all of the information that we just talked about. So the name of this element is potassium. The atomic number of potassium is 19. So that means that there are 19 protons, and since this is a neutral atom, that also means that there are 19 electrons. Remember, protons have a positive charge and electrons have a negative charge. Neutrons are neutral, they have no charge at all. So now the mass number is 39.098. To find the number of neutrons, we take the mass number and we subtract the atomic number. But remember, we're looking for whole numbers. You can't have a partial number of neutrons. So we're going to round this to 39, and 39 minus 19 gives us 20 neutrons. So using the tile on the periodic table, you should be able to figure out the number of protons, the number of electrons, and the number of neutrons that a neutral atom will have. So now let's talk about the difference between the mass number and the atomic mass. Remember, like I said, the atomic mass is what you will usually find on the periodic table. So the mass number is the sum of the number of the protons and the neutrons in the atom's nucleus. The mass number is going to be different for all of the different isotopes of an atom, and we'll talk about what an isotope is in just a minute. So each isotope of a particular atom will have a different mass number, and the mass number is always a whole number because it's number of protons plus number of neutrons. The atomic mass is the weighted average of all of the masses of all of the different isotopes of an atom. So it will be the same no matter what isotope we're talking about, and it is almost never a whole number. Later in this objective, we're going to learn how to calculate the atomic mass using all of the different isotopes, but first we have to learn about what isotopes are. Okay, so let's first talk about atoms. Atoms are the basic building blocks of all matter. Atoms can join together to form molecules, which in turn form most of the objects around you. Everything we see is made up of atoms. Atoms are composed of particles called protons, electrons, and neutrons. This should be familiar information to you already. And again, protons are positive, electrons are negative, and neutrons are neutral. So this is the way that we write the symbol for the atom. It would just be the letters of the atom. So now let's talk about isotopes. Isotopes are atoms of the same element that have the same number of protons, but they'll have a different number of neutrons. So for example, an atom of magnesium will always have 12 protons, but it could have either 12 or 13 neutrons. There are two different ways that isotopes can be written. The first would be to write the name of the element with a dash and then the mass number after the element. The other is a little bit more symbolic. So you'll have on the left side the mass number over the atomic number followed by the element symbol. So no matter what isotope you're dealing with, the bottom number will always be the same. It will always tell you the number of protons or the atomic number. In the different isotopes, the top number is what's going to change. So here is an example of the three different isotopes that carbon has to give you an idea of how isotopes differ. So all three of these are carbon. They're all going to have 6 protons and all going to have 6 electrons. But carbon 12 is going to have 6 neutrons. Carbon 13 is going to have 7 neutrons, and carbon 14 is going to have 8 neutrons. So next we're going to talk about ions. Ions are atoms that have either lost or gained electrons. So remember that electrons are negative, which means if an atom loses electrons, the atom will overall become positive. And if an atom gains electrons, since it's gaining negative charge, overall the atom is going to be negative. So you should be able to determine not only if an atom will become positive or negative based on lost or gained electrons, but you should be able to tell me the overall charge the ion will have. So if calcium has lost 2 electrons, that means it will have a +2 charge. So that's how we write that. We write the element symbol with the charge in the top right corner. If chlorine has gained 1 electron, that means that its charge will be -1. And here, selenium-79, that tells us which specific isotope of selenium it is, has gained 2 electrons. So you want to write the mass number and the atomic number on the left side, like we do for the isotope notation. And then it is also an ion because it says it has gained 2 electrons. So it will be -2. So this picture here combines an isotope and an ion notation. So the specific isotope of magnesium is magnesium-26, which means that it will have 14 neutrons, and it has lost 2 electrons, which means overall it has a +2 charge. So now let's review some of the similarities and differences between atoms, ions, or isotopes. So I want you to take a second and think about what does an atom, isotope, and an ion of chlorine all have in common. So both an atom, isotope, and ion of chlorine will have the same number of protons. Because remember, the protons tell us the atomic number, which tells us the identity of the atom. So if it is chlorine, they will all have the same number of protons, whether it's an atom, an isotope, or an ion. Okay, so now we want to take a second to think about how ions are different from atoms and isotopes. So now remember, ions have to do with gained or lost electrons. So ions will have either a positive or a negative charge based on whether they have gained or lost electrons. Both atoms and isotopes are neutral and have no charge. Okay, so now we want to take a second to think about how isotopes are different from atoms and ions. Okay, so now remember, isotopes will have a different number of neutrons from each other, which means they will have a different overall mass number. Okay? So you can have 2, 3, 4, 5, or even more different isotopes of the same element because they will all have different numbers of neutrons. So that is objective 1A on atoms, ions, and isotopes. Please see me if you need help with any of this.